There's a sign-in sheet. I can try. You guys can try. Or no cards. All right, guys. So did you all see the review I posted on Blackboard? Okay. You should definitely go there and look through each section because it tells you exactly like the rules that you need to know, like the derivative of log or natural log or something. You know, it lists every single thing out. So just go over that or make a note card with it so you have all the rules next to you. But you can't use that on the exam. Okay. Yep. Okay. So, how many of you guys are struggling with natural logs or logs in general? Okay. So, just calculus. Okay. Actually, this unit, I don't mean to like sound, you know, whatever, but this unit should be one of the easier units compared to everything else. So if you just give it some more time, I promise you'll understand it way more than like hydrostatic forces or something. Okay. Yeah, they will be on this one. So just quickly what a log and stuff is. I don't know if they went over this, but so if you have the equation y is equal to b to the power of x, did they show you guys this on the very first day when they introduced logs? Yeah? Okay. Yeah. So if I were to rewrite this, I can rewrite it as the log of base b, because that's what the x exponent is to the power of, base b of y, then I can know the exponent which that number is raised to. So it's like a quicker way of figuring that out. So if I have 2 to the third power equal to 8, then if I have log of base 2 of the value 8, I can get 3 out of it. Okay? Most people in biology use it with base 10. Do you guys know for what? For pH, because it makes it easier to work with. Otherwise, because you know you have pH of 7, which is water, pH of 8 gets more bitter. Instead of saying times by 10, they use numbers 1 through 14 or something. So that's a quick intro on logs, and they do help you find the derivative quicker, like we found with y prime and stuff. So to the first problem, the natural log of 6.75. Okay. When you see a decimal, the first thing that you should most likely do is turn it into a fraction. Okay. You can simplify this fraction to 27 over 4. That can be even more simplified or written in terms of smaller numbers. 3 cubed over 2 squared. One of the properties that we know is when something is being divided inside a natural log, it means subtraction. when we simplify it. So we have the natural log of 3 cubed minus the natural log of 2 squared. And that could be rewritten as 3 natural log of 3 minus 2 natural log of 2. Any problem? It uses just the basic property that when they're being divided, you can separate them out. We're good to move on? Yes? Natural log of the square root of 12, or the cube root of 12. Okay? We know that the cube root is just to the power of 1/3. So this can be rewritten as 1/3 times the natural log of 4 times 3. 4 is 2 squared. And since it's being multiplied, we can just add them. So this can be simplified to 1/3 times 2 natural log of 2, because we brought the exponent down, plus the natural log of 3, close parentheses. And those should be easy points for you guys. They just use the basic rule of bringing the exponent down, addition, and multiplication, those properties. Good? We have the log, it's 0.5 of 32. What property do you think we can use here? So there's two ways to do it. But what property do you guys think we should use? Yep. Natural log of 32 over the natural log of 2 to the 1, -1. You guys see that? Because this is 0.5, that's 1/2. That's 2 to the -1 power. So you can bring the exponents down for that. But 32 can be rewritten as natural log of 2 to the 5th power. And then we have -1 natural log of 2. Okay, this 5 can be brought down, so our answer will be -5 because the natural log of 2 crosses out. Can you guys think of another way to do this? The second way is to set this equal to y. So y is equal to log of 0.5 of 32. Then what you can do is use the definition of what a log should be, as I said before. So it would be 1/2 to the y power equal to 32. Okay. This is using that definition of y equal to b to the x. Therefore, we have 2 to the -y equal to 2 to 5. Using property of exponents, -y is equal to 5. Therefore, y is equal to -5. Both ways are correct. I would go ahead and just do the top way, but this is also valid. So if you guys like, some of you may like the second one, you can do that. part B on number 9 is the log of base 81 of 3. What method do you guys want to use? The first method? Yep, that's the quickest method. So we have the natural log of 3 over natural log of 81. Okay? So this is equal to the natural log of 3 to the first power all over the natural log of 3 to the fourth power. The exponents come down. We're left with 1/4. Are you all good with this problem? So those should all be easy points. And if you don't understand it, make sure you do. You don't want to mess that up. Any questions? So we have for number 10a, y is equal to 10 to the exponent tangent of x plus log base 10 cosine of x. And we have to find y prime. Since this is 10 to some power and these are added, this can be rewritten as 10 to the tangent of x times 10 to the log base 10 of cosine of x. Using our property of logs, 10 to the log of base 10 goes away, so we're left with cosine of x. Okay? We're trying to find y prime. The derivative of cosine is negative sine. So negative sine of x times 10 to 10 of x plus cosine. We need to rewrite it, but that can be rewritten as 1 over secant of x. And that matters because when we take the derivative of 10 to the tangent of x, we have 10 to the tangent of x, natural log of 10 times secant squared of x. That's why I wrote cosine of x this way, because the secant squares can be simplified. So in the end, our answer is 10 to the tangent of x times the quantity of negative sine of x plus natural log of 10 times secant of x. Taking the derivative of this is just remembering the rule that you have the same thing times the natural log of what the base is times the derivative of the exponent. And all those rules are in the review that's on Blackboard. Any questions on that? It's just taking, if you remember that you need to multiply by natural log of 10 or something, then after that it's really easy. It's just doing a derivative. For b, we have y is equal to log base 10 of x cubed times 10 to the exponent of secant of x. What property do you guys think we should use? These are being multiplied. Well, this is to the base 10, but these are being multiplied. So the first thing we can do is break them into separate components, and then we can use that other property. So it's log base 10 of x cubed plus log base 10 of 10 to secant x. Okay. The first part can be rewritten as natural log of x cubed over the natural log of 10. The second part since this is log base 10 of 10, those that can go away, and we're just left. That equals 1, and we bring the secant of x down, so it's just secant of x. We still haven't taken the derivative. This is still just simplifying y. But after that, well, we have to remember that this 3 can come down. So when we take the derivative of it, it should be really easy since we're with a lot of constants now. So y prime is equal to 3 over the natural log of 10, which is just the constant part of this, and the derivative of natural log of x is 1 over x. So we multiply x in the denominator. And the derivative of secant of x is secant of x plus tangent of x. Or multiply. Any questions on this?
Would it be wrong to, like, if you forgot to bring the 3 and run the natural log of x, so you have
Yeah.
1 over x cubed times like 3x squared, and they take off and it be simplified all the way?
Yeah, they take off for not being simplified all the way. But. What did you say?
I think it ends up being
Yeah.
anyway.
3x squared with 1 over x. But this would make it easier if you brought the 3 already down already. So taking derivatives with natural logs and logs can be really easy in that case. Any other questions on that problem? No? Okay. So now we have y equal to, so this is c. The square root of 4x minus 3 quantity cubed times 3 minus 2x quantity to the 4th power all over the cubed root of x cubed plus 8. Okay. So what's the first thing that we should do? Natural log of both sides. So since natural log can never be negative, we want to show absolute value signs. So the natural log of the absolute value of y equal to, if we're to take the natural log of this whole function, I can rewrite that, or we can just rewrite it being simplified as we go. So since that is cubed, we can, and square rooted, we can bring out 3/2 times the natural log of 4x minus 3 plus, this is being to the 4th power, 4 times the natural log of 3 minus 2x I do believe you need absolute value signs here. Plus or minus 1/3 times the natural log of the absolute value of x cubed plus 8. Are you guys confused when absolute value signs go or don't?
Yeah. Really think about putting it in. And restrictions. Yes, we talked about that today also.
Here is, on the exam, they don't show any restrictions. On the practice exam, that's why none of the answers I put showed restrictions. But they haven't said this, or I don't know if this is completely valid, but I don't see anything wrong with this if you put absolute value signs on everything. Okay?
But then you just do right?
But then they go away.
Yeah, and that's
Then the absolute value signs go away. But in this step, just put the absolute value signs. I'm like 99.9% confident that that won't be wrong. Okay? So then we take the derivative of all of that. The derivative of the natural log of the absolute value of y is y prime over y. That's equal to 3/2 times 4 over 4x minus 3 plus we have 4 and then 3 minus 2x at the bottom and a negative 2 on top. Minus, where's that? Minus 1/3. Denominator is x cubed plus 8. Derivative of that is 3x squared. Okay. Any questions on that part? I mean, if you just remember all the properties, this is simple algebra. Like what we have there. So y prime is equal to y times the quantity of 6 over 4x minus 3 minus 8 over 3 minus 2x minus x squared over x cubed plus 8. And that's the answer. And since y is really long, you can just put y in the answer. You don't need to rewrite it. So any questions on this?
So this one had any restrictions? No, how good is it?
In the answer sheet, they don't show any restrictions. So I'm going to leave it like that.
Why do they give you an answer sheet with the restrictions so that you
Now
they kept me around, look up here.
I can see.
Like x can't equal 2 or negative 3, right? Because that's it. Why?
Yeah, don't worry about restrictions on these.
No.
Or on this practice exam, they don't show restrictions. I'm just gonna put it at that. No, they didn't do that on purpose. Though. I know that for sure. Or I'll email Lawson today, and if she responds back, I'll email you guys.
Yeah. Just say for any restrictions.
I'll put an announcement on Blackboard in Reach, okay? So go there instead of checking your email, because it takes me a while to email everyone.
You type in our email.
Like I have to email every section at, like, I can't email everyone at once. So, but okay. Y is equal to, all right, comments. Cosine of 2x, and everything is to the power of tangent inverse of x. And they just tell us that cosine of 2x has to be greater than 0. There we go. So what's the first step again? Natural log of y is equal to, we can bring the tangent inverse down. We take the derivative. Y prime over y is equal to tangent inverse of x times the derivative of so -2. So you use the rule, we have cosine of 2x at the bottom, and then the derivative of cosine of 2x is -2 sine of 2x. Plus the natural log of cosine of 2x. And the derivative of tangent inverse of x is 1 plus x squared. And then you can bring y to the other side. And that's pretty much it. What do you mean tangent of 2x? Oh, wait. Yeah. This? Yep. Yeah, you can pull the negative out. Oh, I'll rewrite it. I didn't want to rewrite it. So y prime is equal to y times -2 tangent inverse of x tangent of 2x plus the natural log of cosine of 2x all over 1 plus x squared. And there is another way to do this. That's with b. You guys remember method 2? Where you do e to the natural log of cosine to the tangent. Yeah. That way you can also do it, but I just prefer this method always. Do you guys want me to show you the other method? No? Yeah. Because it's really easy to take the derivative of natural log and stuff. All right, guys, let's move on to page 2. So first question, are you guys all done with your homework?
I finished, like,
That should be done on Sunday night or Saturday. Like, when did you guys get it?
We tested on Thursday last week, so we didn't get it last.
yeah, CSR.
They don't let you guys in.
Oh,
It's back up now.
the way, even if I didn't understand how to do the homework, I BS my way so that I finished it.
You press the word size,
Or, like, try to get it done so that you can focus only on the test tonight. Okay? Like, that should be a rule. Because if you do the homework after this, how many of you guys have attempted this test before coming here? Well, a few people, that's good. But, like, you should definitely come here and then watch me give you the solutions, not just write the solutions and then look at them later on. That's, okay? That is true.
many of them.
So for 11, we have natural log of cosine of x minus x squared equal natural log of 3y plus 2 minus natural log of 4. You should always try to isolate all the natural logs to one side. So we have negative x squared equal to natural log of 3y plus 2 minus natural log of 4 minus natural log of cosine of x. Okay. What's the next step? Yeah. Well, yeah, we have to combine them first, since these are all being subtracted. Or the easiest method would be to combine them. So we have the natural log of 3y plus 2 divided by 4 times cosine of x. Now we do e. We have e to the negative x squared equal to 3y plus 2 all over 4 cosine of x. And I'll just write down here, y is equal to 4 cosine of x times e to the minus x squared all over, or minus 2 all over 3. So any questions on this problem? All of them just use the basic properties, like these are being subtracted, so you can combine them by dividing them. So it's not that hard in the end. The integrals might get hard. So moving on to 12, we have e to 3 times the natural log of x minus natural log of y plus the natural log of e to 2x, that whole thing squared, divided by e to y squared, and we have to simplify it. So what is the first step? The first step. First step should be,
ln x over like e to the ln.
yep. So this is a e to the exponent, and then something's being subtracted in the exponent. We can rewrite it as e to the 3 natural log of x divided by e to the natural log of x or y. And then this part we can keep. That part we can separate it out. So natural log of e to the 4x minus the natural log of e y squared. This is 4x because of 4x squared.
I think we just get
No.
like x
Sorry.
over y.
This is 4x, not 4x squared. What was the question?
Confused about the first part.
This part?
Yeah.
So say I have x to the 5th divided by x cubed. We know that's x squared, right? Because this is equal to x to the 5th minus 3. The denominators can be treated as a negative exponent on the top, right? That's the property of exponents. This is e to something positive, and then something subtracted being from it, which is a denominator. That is such as x squared quantity cubed. That's not x to the 8th. That is x to the 6th. When an exponent is being raised to an exponent, you multiply them. When I have x squared times x squared, that's equal to x to the 4th. Then we add them. This one is being raised to an exponent entirely. If this was a 3, let me use 3. This would be a 5. Yeah.
But on the first step, could you just go ahead and write e equals ln x cubed over ln
Yeah.
y?
Yeah. A lot of these you can do it in one step or something. So then, if we go to the answer, which I'll just write to the right here. So this overall would be, since this is 3 natural log of x, that is x cubed, and e to the natural log, that cancels out. In the denominator, e to the natural log cancels out. So we're left with x cubed over y. This is a natural log of e. We bring the exponent down, and the natural log of e is just 1. So that's plus 4x. We bring the exponent down. Natural log of e is again goes to 1, so we have minus y squared. Do you guys know what natural log is? Log base e. So when you have natural log of e, that's log base e to e, which is 1. Any questions on this problem?
Is it wrong? Is it wrong to have done like? Oh, you want to do that? I see. Never mind.
I'm still confused on how you went from E to X squared to the X.
Which one? This one, right?
The X squared.
Right here? Okay, let me just go over here quickly. So I have e to 2x, that whole thing squared, right? You can rewrite, this is equal to essentially e to 2x times e to 2x, right? Right? And if you rethink of that other rule, when you have same base, but they're being multiplied, so this is e to 2x plus 2x, so that's equal to e to 4x. If this made more sense. But generally, when you have an exponent that's raised to an exponent, you multiply them. You don't raise it to that power. So this is x to 15. Yeah.
Would it be incorrect to pull that 2 down in front of the natural log and then you get natural log e raised to x? Is that incorrect there?
Yeah.
So you have like 2 ln e to the 2x, so you do 2 times 2x.
Yeah.
And then if you,
So you have 4.
Or it could just be one.
no, you could, okay. You should multiply them out because the rule applies to the number here, since this is going through the whole thing, okay? Otherwise, in different examples, it will lead to trouble.
You can't move that 2 down.
No, because the rule applies to the exponent, that which, so it would be, let me rewrite that here. So then that can be taken as e to the 2x times e to the 2x. Okay? Then you can separate them and then bring them down. And then you can get 4x. But doing it the other way could be like, with different examples, it could lead to trouble. Any questions on this right now? No? We are good to move on? We can do some integrals now. Okay, so 13a, we have just another property they probably told you guys in class, but e to 0 power is what? 1. So if I do the natural log of both sides, we get natural log of 0. Did I do that right? No, I did that wrong. Yeah, I did that right. Yeah. E to 0 is equal to 1. Natural log of both sides, 0 is equal to the natural log of 1. Okay? So just know that it's helpful in the integral. x cubed times 10 to minus x to the fourth dx. What's the first step? U is equal to negative x to the fourth. Du is equal to negative 4x cubed. So this is equal to negative 1/4 times the integral of 10 to negative x to the fourth times du, which would be negative 4x cubed dx. So if you guys are good with that step, then it's really simple. You use the, as I put in the review, when you do an integral of something, a constant raised to a function, this is the form it should be. So we have negative 1/4. Then what you need is 1 over the natural log of the constant. So this is 1 over natural log of 10 times the function itself, 10 to negative x to the fourth plus c. So this is just something that you need to remember that you need. And all of it is written on the review. Yeah. Yeah. Yeah.
Can you find a way to do that again?
Why I have 1 over natural log of 10? That's just a rule when you have a constant raised to a function like this. I'm sure there's a mathematical proof, but in the end, you need 1 over the natural log of 10. No, it'd be 1 over, if this was a 5, it would be 1 over ln of 5 times 5 to the negative x. Can I erase this? The integral of log base 10 of x cubed all over x dx. What's the first thing that you should do whenever you see a log, essentially? Turn it into like a natural log thing. So this is the integral of the natural log. We'll just do we'll bring down the exponent. So 3 times the natural log of x over the natural log of 10. And we have dx over x. In this problem, it was nice because our u would be the natural log of x, and this entire thing would be our du. So we already have that. So we don't need to multiply in by anything. And that's equal to that's our u, that's our du. In the end, we have 3 over natural log of 10 times natural log of x quantity squared. Natural log of x quantity squared all over 2 plus c. So then that would be the answer. So it's u, so it's the integral of u, so we have u squared over 2. Any questions? Can I erase this? So we have c from 0 to negative natural log of 2 of dx. So it is e to the negative 3x dx. They write it in the denominator, but I just brought it up. So what should our u be? Negative 3x du is equal to negative 3 dx. So this is equal to negative 1/3 times 0, from 0 to negative natural log of 2 of e to negative 3x times negative 3 dx. So we have our u, we have du. This is equal to negative 1/3 times e to the negative 3x from 0 to negative natural log of 2. Now we don't have u squared, or sorry, this isn't our u. The exponent is our u. With the rule for the integral of e, you just rewrite whatever the e term was, and then you go with your limits. Good? You have a question? So then, yeah, we solve it. We have negative 1/3 times e. If we put negative natural log of 2 in it, we have e to 3 times the natural log of 2. We know that's going to turn out to be 8 because the 3 goes on top. And then it's e to the natural log power minus e to 0, which is 1. So this is negative 1/3 times 2 cubed minus 1, which is negative 7/3. Any questions on this problem? You just needed to know what it meant taking an integral of e to the power. Otherwise, it's doing an integral, which should be easy for you guys to know. Any questions on this problem? So d is 2x plus 3 divided by x squared plus 3x plus 10 dx. Who wants to tell me why this is the easiest problem on the exam? Yeah. So this is our u. This is our du. And when we have du over u, that's the natural log of the absolute value of x squared plus 3x plus 10 plus c. Are you guys good with it? So the only thing, even remotely tricky would be knowing to put the absolute value sign. So we're on our last one. Any questions so far? So the lower limit is pi over 8. Upper limit is pi over 4. Cotangent of 2x dx. What is the first step? It's breaking into sine over cosine, not just automatically going and setting this like a u. Okay. So we have 1/2 from pi over 8 to pi over 4 cosine of 2x divided by sine of 2x dx. We set our u to sine of 2x. Our du would be 2 cosine of 2x. So we multiply the top by a 2 and the outside by 1/2. So this is equal to 1/2 times the natural log of the absolute value of sine of 2x going from pi over 8 to pi over 4. Any questions so far? So then we have 1/2 times the natural log of sine. When we put pi over 4 in, we get pi over 2 minus the natural log of sine of, when we put pi over 8 in, we get pi over 4. This is equal to 1/2 times the natural log of 1 minus the natural log of 1 over square root of 2. Natural log of 1 goes to 0. 1 over square root of 2 is equal to 2 to the minus 1/2. So then that is equal to negative natural log of 2 to minus 1/2 all over 2. We bring the minus 1/2 down. The negatives cross out or make a positive. We are left with natural log of 2 over 4. This board doesn't move, but I'll rewrite it. Any questions, guys, on this problem?
So when you integrate it, you used to like say 2 natural logs. Like we have natural log of and then like 2 plus 2. Like we have 1 natural log.
Yeah. That's it, guys. If you have any homework questions or something, you can come. Okay, bye. The test I put on Blackboard?
Oh, yeah, like just the content, like, you know how you have like the study guide training post, did you post that? Because I went here, and then it's kind of like the old, like,
The best way to go is down from, and then you go here.
Okay.
You go to my name,
Okay, that, so much better.
and then you have the reviews that I post,
All right.
and there's a video and the exam.
All right, thank you. 'Cause I was going like,
Yeah,
it was like left hand and right hand derivative stuff. I was like,